Hi children, welcome back. When a transversal is drawn to the two parallel lines, there are three conditions which will be get satisfied. One is alternate angles are equal, the Z shape. The second thing is corresponding angles are equal, and the third thing is sum of the interior angles on the same side of the transversal is supplementary, that is 180 degree. I mean to say that when a transversal is drawn to two parallel lines, the two parallel lines here, and on drawing the transversal like this, there are four pairs of corresponding angles we are getting in this. Out of that, I'm showing you only one pair of corresponding angles. So these are the two angles. We are considering this as corresponding angle. So these two angles are equal. Okay, now why do we need this? If I consider this imaginary line, you can find there is a shape of triangle here. Again, in this triangle, if this is the parallel line drawn, then these two angles are equal. So let me remove that line. This is the, and the second property that we have to know is, I have explained you about congruent triangles. So here also we need to know about congruency, and which is nothing but SA's congruency criteria, which says if two sides and the included angle of a triangle, if it is equal to the two sides and the included angle of other triangle, then the two triangles are congruent to each other. That is what SA's criteria. And the meaning of this is, if I consider the two triangles, congruent means if you just superimpose one triangle over the another, they have to exactly just coincide. That is what congruency is. Okay, now as you can see, I have considered the two triangles. If you want to apply SA's criteria to this, let me show you. Here is these two lines. I have darkened this. So these two lines are, okay, so one more time. Here is these two lines. Let me take this as a side. Another, this is the another side I'm considering here. So two sides out of SAS. SAS stands for side, angle, side. Okay, so two sides I have considered, and angle. Out of the three angles, you cannot just simply consider any angle. The two sides, these two sides, they are just having the common endpoint, common vertex here. These two are the common vertex. The angle obtaining at the common endpoint of these two sides which we have considered, that angle only we have to consider. Here is. Then only you can able to consider SAS. Three different ways we can relate two sides and an angle in the triangle. Then you can say that these two triangles are congruent. Okay, so this is another thing just I wanted to recall. Then the third thing is it's all about similar triangles. Similar means they are equiangular, but the ratio of the sides is always same. That is, the sides are in proportion. Okay, so that is another thing you have to know here. The corollary of BPT that we have to know. The corollary of BPT says when you draw a parallel line, then there will be the new triangle, the baby triangle forms inside that mother triangle. The sides, the three sides of this baby triangle is in the same ratio with the three sides of the mother triangle. That is what corollary of BPT. Let me explain you that. Here is corollary of BPT. If a straight line is drawn parallel to a side of a triangle, then the sides of the intercepted, that is baby triangle, will be in proportion to the sides of the given triangle, that is the mother triangle. So here is the mother triangle, and here is the name given to the three vertices of the mother triangle ABC, and I'm considering the parallel line. Okay, there I'm getting the three vertices for the baby triangle. They are A, M, N. Okay, so the sides of this mother triangle, that is AB, BC, and AC. Then the sides of the baby triangle AM, MN, AN, they are in proportion. That is, proportion means AB divided by AM is equal to BC divided by MN. Then it is also equal to the third side, that is AC divided by AN. So this is the corollary which we have to know. If you are familiar with these three concepts, then we can able to prove a theorem given in 10th standard. Theorem says if two angles are equiangular, then their sides must be in proportion, and we will prove that theorem logically by using these three previous knowledge. Okay, let us consider the statement of the theorem. The sides of two equiangular triangles are in the same ratio, that is the sides of two equiangular triangles are in proportion. That is what the statement is. Now, with reference to the statement, we are considering the diagram. The statement is all about two triangles. The speciality of the two triangles is they are equiangular, and we are not bothering about the sides. So that means let us consider two triangles, a bigger triangle and the smaller one, that is mother triangle and the baby triangle. Here is, so the two triangles I have considered, and we need to explain the diagram in our own sentence by considering the side heading as given or data. So in order to explain the diagram, we have to give the names to the vertices of the triangle. So start giving the names. Here is the three vertices of the mother triangle is named as ABC, and the three vertices of baby triangle, let me as PQR. Then after giving the name, let us explain these two diagrams in our own sentence by considering the side heading as data or given. Here is in triangle ABC and triangle PQR. Why I have taken in? Because it is having certain speciality that we need to explain here. What is the speciality it is having? You will find that in statement. In statement, it is clearly mentioned that the angles are equal. That is, the corresponding angles are equal. Okay, so let us relate the corresponding angles here. The first one is angle BAC of mother triangle and angle QP of baby triangle. They are equal. Then angle ABC of the second vertices of triangle ABC and the second vertices of the triangle PQR, they are also equal. Similarly, the third angle, remaining angle, obviously it has to be equal. Okay, done. Then after that, what is the task assigned? Task is if the angles are equal, sides are in proportion. That is what the task is. The side AB of mother triangle is in the same ratio. So PQ. Then same ratio means equal. Consider the third side, second side. So B is equal to Q and C is equal to R. Line joining BC and line joining QR is BC and QR. It is in the same ratio. Okay, then the third side is AC, the remaining side, and P, RP. So these three sides are in the same ratio. That is what we need to prove. Then the information given in the diagram in the statement is not enough for us to prove the theorem. So for that, what I am doing is I am considering the 2 points on the sides of the mother triangle. Here, mark M and N on AB and AC. How? What is the condition? Such that the length of AM must be equal to the side of the baby triangle, that is PQ. Similarly, AN must be equal to the another side of baby triangle, PR, like that. And then M and N are joined. Okay, here is, I have joined M and N. So before I start proving, I am considering one of the angle here as equation number 1. Okay, now proof. Let us compare this triangle AMN with the baby triangle PQR. Okay, and we will prove that this triangle AMN and triangle PQR one and the same. I mean to say, we need to prove that these two triangles are congruent. So we are using SAS congruency criteria. Remember, this angle P is equal to angle A. How do you know that? Very simple. It is given in the statement, that is data. So here I am considering angle MAN of triangle AMN and angle QPR of triangle PQR. They are equal. And how did you come to know? The reason is given. So which is nothing but angle. Then I need two sides. Here is the first side. AM and PQ are equal. How do we know that? Yes, we have done the construction in that way. Am I right? We have marked M on AB such that AM is equal to PQ in construction. Let me consider that AM and PQ are equal, and reason for that is construction. And here is the second side coming out. One is PR and AN. What is the reason? Construction. So let me mention that. So that means with that, here is the two sides and the angle. In the two sides, consider the common vertex is A and the common vertex is P in the other triangle. And the same angle we are considering, A and P. That is what we use the word included angle. So that means I can apply SAS congruency criteria and I can say triangle AMN and triangle PQR, they are the one and the same, that is they are congruent. So here is triangle AMN congruent to triangle PQR, and the reason for that is you need to mention that clearly this SAS congruency criteria. If triangles are congruent, the remaining three more elements, they are also equal to one another. Here, let me consider one is I'm taking MN and QR are equal, CPCT. The meaning of CPCT is corresponding parts of congruent triangles. Let me give the number to that as equation 2. And one more I'm taking as CPCT, and it is nothing but this angle M and angle Q. They are also equal, corresponding parts of congruent triangle. Okay, let me give the number to that as well as equation number 3. What is the advantage of this equation number 3? In equation 1, this angle B is equal to angle Q, correct? Now, the same angle Q is also equal to angle M. We can consider axiom number 1. Am I right? Things which are equal to same thing are also equal to one another. I am writing ABC and AMN are equal. Angle M and angle B, they are resembling corresponding angles. Points to remember 1. So use that. These corresponding angles are equal only when these two lines are parallel. In construction, we have not mentioned that MN is parallel to BC. We have just marked M and N on AB and AC such that AM is equal to AN. We have not mentioned that MN is parallel to BC. Now, but here, with the help of this SAS criteria, congruency criteria, I am proving that M and B are equal. That is, they are corresponding angles, and corresponding angles are equal only when the lines are parallel. So here I can mention the two lines MN and BC are parallel. When MN is parallel to BC, then the another concept jumps in, which is nothing but BPT, which says when a line is drawn parallel to any side of a triangle, here the parallel line is MN. We have proved it. It is parallel. If it is drawn parallel, then it divides the other two sides proportionally. Then points to remember. Third one, corollary of BPT. Then the three sides of the intercepted triangle AMN is in proportion with the three sides of the given triangle, baby triangle and mother triangle. Now I am using the corollary of BPD, which says the three sides of mother triangle is in proportion with the three sides of the baby triangle, that is AMN, that is AB of mother triangle is in proportion, that is the ratio of AB and AM must be equal to the second side of mother triangle BC and the second side of baby triangle MN, which is again the same ratio with the third side, that is AC or CA, and the third side NA. Let us use equation 2 and construction here in this corollary of BPD. That is, I am replacing AM as PQ, MN as QR, and NA as RP. Okay. And what are we getting there? To prove the same thing we have considered. That means sides are in proportion. That is what we have proved. The second theorem of 10th standard. Then in the next class we will prove the theorem related with the areas of two similar triangles. And okay, thank you for watching. Happy learning.